Shh, don't worry about it. Medians. Guys, enough. Enough. Okay? Medians. Medians of the triangle go from the vertex to a midpoint. Okay? So, going right into it, the medians of a triangle are the segment. It's the segment drawn from a vertex to a midpoint. Okay? The medians of a triangle go vertex to midpoint. There will be how many of these inside of a triangle, do you think? Three, because how many vertices are there in a triangle? Convenient how this works.
Yeah.
Okay? I know. So the segment drawn from a vertex to a midpoint, so if I kind of guesstimate midpoints here, see how well this works. If I draw these through, okay, it's not too shabby there. This segment then, in the middle, is called, not the it's the, oh, get brain farted. Huh?
Take your time.
I'm working on it. I forgot what it was called. Centroid. Sorry, it's called the centroid. I don't know. I was thinking orthocenter. Orthocenter is the altitudes. The point of concurrency is called a centroid. So medians have something called a centroid.
Sounds like a plant.
Yeah. And the segments that are created in a centroid tend to be a little bit weird.
Sounds like a StarCraft.
Okay. So what happens is, you have, if you look at it, that centroid takes the median and cuts it into two different segments. Everybody see that? You have the point, you have the first part of the segment that is from vertex to centroid. And then you have the other part that is centroid to side. Okay? So there's two segments that are created in this. You have vertex to centroid, and then you have centroid to side. The median itself is made up of those two segments. Are we okay with that? This whole part is made up of those two things. Now, if the median is going to equal, let me write this out. Just the median, think of it as the whole thing, is equal to, it's going to look weird at first, but I have a really nice shortcut to make this work. 2/3 vertex to centroid plus 1/3 centroid to side. That's the official way of doing it. There is an absolute easier way to do so here in a second. Okay? Because what I want you to think of, if you look at 2/3 and 1/3. Correct. Now, what else can you say the relationship between 2/3 of something and 1/3 of something? They're the same denominator. How many 1/3s make up 2/3? So isn't 1/3 half of 2/3? That's all it is. Okay? So what happens is, if I know that the segment from vertex to centroid, for example, is 8, The other side is just half of that. What's half of 8? 4. What's the whole thing? 12. That's it. That's it. That's all that is. So even though it has these crazy fractions thrown in here, there's easier ways to do it, depending upon what you know. Okay? So centroid to side is half vertex to centroid. Centroid to side is half of the vertex to the centroid. I know there's a lot of fractions thrown in there, but once you do a couple of these, you see how fast these things move themselves through. It is quite literally half of 8 is 4. That's it. If I do the same thing going the other way, if this much is 3 from side to centroid, how much is centroid to vertex? 6. Very good. You're doubling. The whole thing then becomes 9. What's a third of 9? 3. The smaller segment. 2/3 of 9 is 6. So there's a little bit of weirdness with the math here with the fractions. Once you get a hang on what segment you're working with, it's really, really easy. You just have to know which one you're looking at. Are you looking at centroid to side or vertex to centroid? That's it. You know what side you're on, you're fine. Ready for your homework? Ah ha ha! Look at you!
I like technical.
Because you're so cool.
And do I get anything for?
All right, guess we're not.
Why is it always have to be all athletes? Why can't she be a musician?
If I see it in the paper, I throw it.
What's your highest rank?
All right.
300.
Yeah, but it's always athletes. What's your highest rank?
300.
Talk to the newspaper.
I was a- I was
But it's not always athletes that are in the newspaper. If you look closely.
That was before I was crying.
Yes. If you look close, it didn't show up as well as I thought, but
I was standing
her
there.
picture was, Miss Starr's picture was in the paper. So Miss Starr, you have to go autograph.
Oh, stop.
Wait, you guys gotta get the print.
So,
You can really tell. Oh, yeah.
I didn't want to over. It's tough to show.
I was standing in the back of the room.
I know,
And
I
we
s-
just realized, that was the point where we just realized that the board was gonna vote against the sky.
Yep.
And it was like, and honestly, right, I lost count of the votes. I was trying to keep count of how many no's we had, and I had lost count because we had so many voting then against it. And there was a neighbor of mine sitting right here, and I put my hand on his shoulder, and I'm like, oh my gosh, let me see, because he was keeping track of our numbers.
That's
And
awesome.
I realized we were winning, and then that's when the newspaper and the radio guy got up to leave, because they're like, can we interview you? And I'm like, yeah. And then he started crying, and then I'm like, no. So.
It's good fun. Reagan, would you mind running out to the FTLA and grabbing those two off the printer then? All right.
See, so mine was political.
Same idea. I mean, if I see you in the picture, I'll print it. So here's the thing. If we go back to the idea here again, you've got, it tells you that something is a centroid. Now, like we've been saying, you have to know the differences between the different values, different topics. So it was vertex to centroid is half equals centroid to side. I know. If you want to, if you think it's, yeah, because I just read it as cent.
Yeah. Which is this?
Roy.
Latin root for 100. So I'm not sure how that-
Whatever. So if D is that centroid, and this chunk of the segment from vertex to centroid is 12, what's the other part? 6. What's the whole thing then? You may be right.
I'm all blurry.
It's great. Because you're right, it was in the very back.
It was the DeKalb County Board loving you guys. So we were trying to have the neighbors. Empower your people.
And then the whole thing's changing. So it looks a whole lot worse than what it winds up really being. Okay. It's the idea that you keep with which part of the segment are you working with? All right. Actually, you know what? I think I have this one. I printed out a couple of examples so we didn't have to keep drawing diagrams for this stuff. Let me pull this one. I think I have this one already for us. The answer is yes. Shake the magic 8 ball. Outlook looks very obvious. Yeah, I have this one printed out for you. Hey, Whiskey, we're not playing Tetris, man. Put the computer away. Yeah, put the computer away. We don't need that now.
Yeah, you're done. You're unplugged.
I'm with you. Tetris is great, dude. The flip phones, yes, or the actual working Game Boy.
Yeah. Oh, yeah.
That's all we sat there and did. Oh, yeah.
Was it not?
No, that's Tetris. No, that's Space Invaders where you go around and you shoot upward. Tempest with the dial, you spin the dial and you shoot the. Oh, Tempest was like, oh. I used to walk up to. We lived at Lincoln Racing and University. There was a 7-Eleven on Lincoln about a block up from where we were at, and they had a Tempest machine. So I used to walk over there and play Tempest. My parents would give us a quarter, my brother and I a quarter, and we would walk up the block and go play Tempest because. It was on our way to where the next door to that was like an electrical supply company where my grandparents worked. So we would walk over there and we'd have lunch with them and then we would go and play tennis. Now remember, this is living in Chicago in late 70s, early 80s, where I'm 6, 7 years old and I'm just walking down the street.
Isn't that amazing? Now your parents would go to jail for that.
Correct. All right. So this one is the problem on the bottom, guys. It's the bottom of the first page. Okay. Now remember, what does a median do? A median goes from the vertex to a. To the midpoint. Very good. That's what I was getting at. So we know that if all of these guys are midpoints, that means U's a midpoint, V's a midpoint, T's a midpoint, which therefore means that you can figure out sides going around. Because remember, a median connects vertex to a midpoint. It goes through what's called the centroid. All right, that's where you have to make sure we be careful with the vocabulary. So, just starting on the outside of the triangle here, we know that this part is 5, so it means PU has to be 5. RT is 3, TP is 3. RV is 5, VQ is 5. Okay? Excuse me. I think it was supposed to say RPQ is congruent to RQ, but I think it should have been R. Anyway, so you have all this other information now. So if SU is 2, what's RS? 4. And what's the whole thing? 6. What's the perimeter of the entire triangle? 26. How do you add up how do you find perimeter?
Add up all those.
You add up the sides. You're at 5, 5, 5, 5, and 6. 26. See how fast this is? And that's what happens a lot of times. Because it sounds like, when you start thinking about, when I wrote up, you know, the whole median is equal to 2/3 of one part, 1/3 the other part, it can get messy, okay? Because there are two ways of writing this out. The whole median equals 2/3 vertex to centroid plus 1/3 centroid to side. So yes, it can look a little bit weird if you're dealing with trying to find the entire thing. But if you know one part of the actual median, it's fast. It's so much faster. Okay. There will be a time that we will need to use this though, just so you guys know. We will have to use that. But, exactly, we'll have algebraic expressions. But what happens to those algebraic expressions, they're always going to have some factor of 3 that cleans itself up. So it's not going to, you don't have to worry about it. But you also have a calculator.
Yeah.
Let's see, you guys also have, I think, this one above it.
Yeah.
Take a couple minutes, look at the diagram, start with the diagram, and build out. What's there?
AW's 12, but then
Yeah.
6 or 9. Yeah, that was kind of.
Oh, wait, this one?
There's a typo.
So what it is?
So B dice supposed to be 6.
It should be RW is 12.
Yeah.
Shouldn't it be
Yes, RW should be 12. Yep. Thank you. I didn't realize that. There you go. Take a couple of minutes. Don't look at the questions first. Fill in the diagram, knowing that you have centroids, and figure out what you can do from that information first. Touche. All right, so let's see here. We have a centroid. If RS is 4, what's SU? 2. Okay. Okay. We know that we have all of those midpoints. RV is 6. It says that TV, the whole thing is 9. So the whole median TV, the median is 9. So TV is the whole thing, which means that 2/3 of that is the median, is from, some vertex to, let me rewrite this. 2/3, the whole thing, is vertex to centroid.
You did write it better.
What's that?
You want us to like write that all out?
No, you don't have to. I'm just trying to remind, just writing it so you guys remember what's going on. So 2/3 of that whole chunk is that vertex to centroid. So what's 2/3 of 9? 6. 2/3 of 9 is 6, which means this part is 3. 2/3 the whole is vertex to centroid. 1/3 the whole is centroid to side. Okay? We put that in here as well. So this one has a couple extra ones. 2/3 the whole is vertex to centroid. 1/3 the whole is centroid to side. Now, the reason why I was saying to you guys that the centroid to side stuff and the vertex, this whole section takes a little bit more time because there are so many different ways of writing it out. Whereas with in-centers and circumcenters, it was just one part of the segment you had to worry about. Here, you've got 2 segments, well actually 3, that you could be manipulating one of many different ways to figure out how to solve. So it's the idea of knowing how all the different algebra parts can work itself through to make it work. Okay. What else do we have? So we have RV, that was 6. SU, that was 2. RU is 6, it's the whole thing. RW, 12, that was really difficult. TS was the 6, and SV was the 3. Quick and hands, right?
Mr. Murphy, do you think on this one, why would they ask us RW if they gave us RW?
I think it was a typo.
Do you think it was TW?
It might have been, but it might have been I'm thinking it was a typo because you can't really find TW.
Right, we can assume, yeah.
Right.
Right.
So my guess is just a plain old typo. Okay. It never happens. Typos never, ever, ever happen. Especially with me.
Yeah, we know
Let's make it more interesting. Try to think of
This
I
is
have this
where
one.
I'm done.
Okay. Let me put that out here. There it is. It's one of these. This one. This is where it gets interesting when you have the algebra, okay? So what happens here is that they're going to give you one diagram and have multiple things that attribute to the diagram. You're going to work with the three different medians. It tells you that point G is the centroid. So that means you can use your median formulas. It tells you that CG, so if you think about it, CGE is the whole thing. So CE is the whole. CG is the vertex to centroid. And then GE is the centroid to side. Now what I'm doing here, guys, is I'm just kind of labeling them out first, so that way when I start thinking about how do I set it up algebraically, I know what parts to put where from my formula. Okay? Because it goes from vertex to midpoint. CE is that whole thing, that's the whole median. I'm working with the first problem. You're right, Nelson. The next one, AF, is the whole thing, but that's for the next problem. I'm just looking at this first example. Okay. So now I start thinking about what you know. You know that vertex to centroid is 3x plus 7. You know that the whole thing is 6x. Which of these deal with just the whole and vertex to centroid? The 2/3 of the whole. Okay? That's the reason why I like to write it out in words a couple of times, so I get the idea of what goes where. Okay? So if I know that 2/3 of the whole thing, bless you, is the vertex to centroid, I can write that out. So 2/3 the whole is vertex to centroid. All I'm doing is writing it out. The more I write it out in terms of what exactly is going to go where, the easier everything becomes. So now I have to use 2/3 of 6x equals 3x plus 7. Now, you guys were worried about what to do when you had fractions to multiply in. Now, 2/3 of 6 is going to be easy to do. You know how to type in 2/3 on your calculators? Hit your fraction bar, or hit 2 fraction bar 3, and it'll go 2/3 right away. You have to use parentheses. Get the other calculator, believe me, you're going to be so much happier. Really, 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 really. So if I do 2/3, and all I have to do now is times 6. It tells me what it is. 2/3 of 6 is 4. So 2/3 of 6x is 4x. There you go. So now you get the problem, 4x equals 3x plus 7. What's x? There you go. Thank you. Okay?
He's getting smart.
It's the idea that
He's getting smart.
you write out what you're trying to do before you do it. It is so important with the algebra style problems of this style, okay? It just makes everything cleaner. All right? Let's try the other one. What's that? You don't have to do, I mean, that's why I'm writing it out, because if you start putting it in here, there's not a lot of space. So if you write out what it is, because that's how we put our notes in, it's just complete. That's all. So I do the same thing for FG and AF. So I'm going to put this on a clean one so I can rewrite it. FG is what segment in the triangle? So it's centroid to side. FG is the centroid to side, and AF is the whole thing. So which of these am I going to work with? Yeah, the 1/3. 1/3, the whole thing is the centroid to side. So 1/3, the whole is centroid to side. Now you know which formula to use. You just fill in the blanks. The whole thing was the AF. 1/3 of 9x minus 6 is x plus 8. The tricky part here is to remember to distribute to both terms within the parentheses. And use the calculator. Well, actually, this isn't so bad. What's 1/3 of 9? And what's 1/3 of 6? 2. Okay? So if you distribute the 1/3 to both the 9 and the 6, you get 3x minus 2 is x plus 8. And now you're back to a very easy two-step equation. Subtract x, add 2, and what do you get? You're done. Okay. Let's think about the last one then. The last one then talks about BG and DG. Can I put this on a clean one for the last one? Are you guys all caught up on that? I don't want to go too fast. So BG is vertex to centroid, and DG is centroid to side. So you have vertex to centroid, which is BG, so that is 5x minus 1. And then centroid to side is 4x minus 5. Which of these, oh, do we have that? We didn't write that one out, did we? Oh, we did. Half the vertex to centroid is the centroid to side. And what's another way to write that? If we have half of vertex to centroid is centroid to side. Louder. Yep. That's how it works. That's what happens, guys. There are, let's see, we have 1, 2, 3, 4, 5 ways of writing out centroids. And that's what takes the longest to figure out which one are you going to use. Okay? That's the idea, okay? That's how that one works. So if I double, once you guys figure that one out real quick, and we'll check it. So write it out. If I double my centroid to side, it'll equal vertex to centroid.
Are we gonna write any of this on our
I don't think we need to be honest with you, because we don't use the progression sheets anymore because we're not doing proofs.
Are we allowed to use the progression sheets in the final?
Probably not. But that's later on, because when you have the proofs on the final, unless we rewrite it, it's multiple choice.
Yeah. So you look at, they're showing, and they show you angles that are vertical, and they're saying, why can you say this? And it says, alternate interior angles, vertical angles, reflexive property. So that's what, you're like, oh, duh, they're
Yeah.
vertical angles.
And that's why we try to send it. So if I double that, what's double 4x minus 5? Add 10, subtract 5x, you get 3x is 9. X is?
I just guess,
Alright. So what I want you guys to do tonight then, it's on, so this is 5.4 in the book. It's page 322,
that's a lot of writing.
numbers 3 through 7, and then 33 through 35. 7 problems. I know it's a lot. Okay?
Especially with this. That's just a lot of writing.
Wah, wah, wah.
Sounds exactly like you.
Yes, I whine so much.
You do.
Wah, wah, wah. Okay?
You just want like the.
It's called sarcasm whiskey. Yes, sir. What's that?
Mr. Murphy.
Yes, sir.
What's that?